From the St. Francis Yacht Club in San Francisco, this is the Wednesday Yachting Luncheon, hosted by Ron Young.
Welcome to the Wednesday Yachting Luncheon, live from the virtual grill room of the St. Francis Yacht Club. We hope that you and your family are safe, sheltering in place in a comfortable environment, and we look forward to greeting you back in our grill room just as soon as conditions permit. Many of us sailors remember the delicate moments when you're going up the Santa Barbara Channel and the boat slows down, or the moments during the America's Cups in San Diego when you had to cut kelp off the bottoms of your boats. In those days, kelp slowed the progress of our sailboats, and we wanted to get rid of it. But we've been noticing lately, lots of us, especially when you go to organic food stores and you have sushi, that kelp, or seaweed, as we used to call it in the old days, is quite a delicacy. There are over 65 different species on the California coast alone. Our speaker today began his aquatic career as an abalone diver. That's a kind of cool diver. And all along the California coast, as a recreational sport, people were catching abalone for years. He went on to get a degree in ocean management, environmental economics, and policy at UC Berkeley, and now works as a biologist and diver at Reef Check. Reef Check trains citizen scientists to monitor and restore some of the very ecosystems that Dan dove in when he was a young kid. Dan, welcome to the Wednesday Yachting Luncheon.
Thank you, Ron, and thank you for that great introduction.
Tell me the first time you ever remember seeing seaweed. You weren't thinking this is going to be your job, but there you were, a diver of abalone. Where were you? What did you see?
Yeah, I remember it very clearly. I was 14 years old and I was diving on the Sonoma coast more than a few years ago, for sure. And just that experience of putting on that mask for the first time and putting your head in the water and just being able to see all this beautiful life like right away. It was really a moment that has set me on a life path.
Previous WYL speakers have told us about the incredible value of these kelp forests. So we're anxious to hear what you guys are doing to restore them and to monitor them.
Yeah, today I'm going to talk about California kelp forest and what the work that Reef Check is doing, training volunteer citizen science divers to help protect and restore these incredible ecosystems. Well, before I get too far, let me just talk about what is kelp. So like Ron said, kelp is a type of seaweed. It's a large marine algae, and it grows very large and forms kelp forests, these areas that look just like forests on land, except they're in the water and you can swim through them. Okay, so this is our two species of kelp that we have along the West Coast. We have giant kelp, which is this one in the middle here, and we have bull kelp. So giant kelp tends to grow in more protected areas, and it has this long stipe that goes all the way up, and connected to the stipe are all these leaves or blades, is what we call them. And at the base of the blades, there's a little float, and that helps the plant, reach the surface and stay afloat. And so it's a very, very leafy, full plant. And then our other kelp is bull kelp. And so that has this root system down here, just like giant kelp, but it just has one long stipe that goes all the way up, and then it has one single large pneumaticist up at the very, very top with a whole bunch of these long leaves or blades coming off of that. The floats on the giant kelp are just a couple inches, and the float on the bull kelp starts off as like a little round ball. But as it grows, it gets bigger and it gets really elongated. So it looks almost like a pipe. And so you'll see both of these wash up on the beach, but they'll look really different. I mean, I think the bull kelp, you've probably seen kids like take them and kind of like fling them around like a bullwhip.
Why on the beach? What caused them to die and go up on the beach?
Well, so kelp grows a lot. And even though we call them forest, in one respect, it might be better to think of them as like a grassland. Bull kelp is actually an annual, so it grows every year and then dies off in the winter and then regrows. So these entire forests are like annual forests that come and go. And even giant kelp sticks around for a couple years, but a lot of it gets ripped out in the big winter storms that we get along the West Coast. And so all that all that, material gets washed up on shore, but it also just gets like, pushed all around the reef where it becomes food for numerous animals. And on the West Coast, we have kelp forests all up and down the coast. And these ecosystems are really just incredible places. In my opinion, they are some of the most beautiful places on the planet. Experiencing a kelp forest firsthand, only thing I can really describe it to is like a giant redwood forest underwater that you get to, swim through, kind of fly through with the light rays shining down. They're really just amazing, beautiful ecosystems. But in addition to their beauty, they're also, hugely important, both, economically and socially. There's a ton of fish and marine life that depends on these forests for habitats, and they have a huge, cultural importance for us as well. Many people are very connected to these areas. And not just fish too, but all sorts of, invertebrates, crabs, sea anemones, all sorts of animals, call the kelp forest their home. And as a diver, I just feel really lucky to have been able to spend so much time in these ecosystems. It's something that I've been able to do most of my life. However, in the past couple of years, past 5 or 6 years, we've really seen these ecosystems transform into something more like this. And this is what we call an urchin barren. And so these are areas where the kelp has more or less been eaten by these little purple spiky things called purple sea urchins, which are herbivores. They're a native species. They are not invasive. They are a natural part of a healthy ecosystem. But right now, there just seems to be more urchins than the kelp forest can handle. And we're seeing these barrens develop, these urchin barrens all along the west coast. And these are areas where the kelp has disappeared. It's all been devoured. And a lot of the fish and the invertebrates have moved on as well. These barrens seem to persist for a long period of time. And we know that they tend to have fewer species in them and less of them as well. Along the West Coast, we've seen kelp declines pretty much everywhere. So in Washington, Puget Sound, there's kind of been a steady decline in kelp, most likely due to water quality. In Oregon and Northern California, we had a very dramatic loss right around 2014 and 2015, where we lost up to 95% of our kelp forest. Central Coast, Monterey area, we had similar loss of kelp, or a similar time period, but more patchy. It wasn't a huge dramatic loss. We saw some areas lose it and other areas keep kelp. And Southern California, there's definitely barrens as well that have been around for a while. And there's also an invasive hornweed. So this kind of invasive algae that has moved in and displaced kelp. So all along the West Coast of the US, we're experiencing issues with kelp.
When you say invasive,
yeah,
that sounds kind of like scary. What's that? What do you mean by, in this context, invasive?
Invasive is just a species that comes from a different area. So it didn't used to live here. This one came from Japan and probably brought over the ballast water of ships, and it's come here and kind of taken over. We have invasive species on land. I know, like eucalyptus trees or ice plant, those things that kind of can take over these native ecosystems. Okay, so just to give you guys a little bit more of an idea of what this looks like, I'm just going to play this short video, which really shows going from a kelp forest to an urchin barren, so you can kind of get a feel for how different these two ecosystems are. Sorry for the shaky camera.
So this is the before picture?
Yeah, these are right next to each other. So now we're in the kelp forest, and this is just the urchin barren. Nothing but rock and urchins.
Holy cow. So you call it urchin barren?
Urchin barren, yeah.
There used to be a kelp forest here.
Exactly.
The kelp is gone. The urchin is basically just spreading all over.
Exactly. Yeah. It used to look like that first part where it's all kelp. And now you just have these barrens, which are really striking for all of us. Want to remind folks that it's not just kelp, right? We're not just talking about seaweed. It's really the entire ecosystem is being changed. And so, for instance, the red abalone, which some of you may have had the privilege to eat in the past, there used to be a red abalone fishery in Northern California. And when all the kelp disappeared, there was no food for the abalone to eat. And their numbers just plummeted, it declined drastically, and they had to close the abalone fishery in 2017. So there's no more abalone fishing in Northern California. This is a huge bummer, right? Because, you know, culturally, this is something that I grew up doing. I know there's a lot of communities that depend on it. And economically, there's a huge impact. This was a $44 million industry, and it just disappeared due to this loss of kelp. And this is just one example. There's urchin fisheries.
Can you give us some numbers? How many abalones were being harvested?
I think it was probably around 100,000 abalone per year, but I'm not 100% sure.
And were those mostly caught by professionals? What was the professional spread?
No, so the red abalone fishery was a recreational only fishery. So there was no commercial fishing of red abalone north of the Golden Gate Bridge. Abalone were actually overfished in the rest of the state. And in 1997, they closed all abalone fisheries south of the Golden Gate Bridge. And the only fishery that was left was a recreational only, free diving only. You had to hold your breath to catch them fishery north of the Golden Gate. And yeah, and that one was managed very well. There was always plenty of abalone for everybody to harvest until we lost the kelp forest. And then we lost all the abalone too.
Wow. Many of our viewers know free diving means without using mechanical aqualung or anything like that, stored air. It means just holding your breath and going down.
Correct.
Yeah.
Yeah.
You have good free diving yourself?
Yeah, that's what I grew up free diving for abalone, and that's what I would do. So it was very challenging to catch these abalone because you would go into the cold, frigid water of, you know, Sonoma or Mendocino County. You'd swim on out there. It was generally wavy. Visibility was not very, very good. I mean, those of you who are sailors who've sailed up there, you know the conditions can be rough. And then you got to hold your breath, swim down through all that kelp and search around for these abalone, and then pry them off the rocks. They would attach on to the rocks really, really hard. You'd have to take an abalone iron and pry them off and then swim back up to the surface. It was not for the faint of heart.
How deep would you go?
I would say somewhere between 10 and 30 feet is where the majority of the abalone were, and the majority of the abalone fishing.
How long would you hold your breath?
I think people would hold their breath generally for about 45 seconds to a minute or a minute and a half. That's about the limit of what I can do, unless I'm really, really focusing. In the water, I think the longest breath hold I've ever done is 2 minutes. So yeah, so when we first started to see this as divers, we were really alarmed. It's like, you know, going to your favorite redwood forest one day, and the next day you go there and it's just completely disappeared. And it really happened that fast. It was almost overnight that some of these ecosystems would switch. So yeah, as divers and seeing this firsthand, we really wanted to figure out what was going on. We were in a unique position to figure this out. So at Reef Check, we used our volunteer citizen science divers to go out and collect data on what happened to the kelp. So the first thing that we documented was that there was this mysterious disease called sea star wasting disease that killed off a bunch of sea stars in late 2013. And in particular, there was one species of sea star called a sunflower star that was really decimated by this disease. Sunflower stars are probably unlike any other starfish you are thinking of. First of all, they were huge. They were about 3 feet across, like a yard across, and they were soft as opposed to kind of hard and leathery. And they would move. They'd kind of crawl along the bottom at a speed that you could really see, whereas most sea stars, they don't look like they're moving, even if they are, because they're going too slow. So we know we know sunflower stars eat urchins. And in late 2013, we saw them pretty much disappear, as this graph here shows. This is the population of sunflower stars over time. And you see right in 2014, it goes almost to zero. And we have seen almost none in the state since around that time. The other thing that happened was there is this warm water that happened in 2014, 2015. Those of you in California will remember the extreme drought we were in those years, the huge lack of snow. And that was due to this like mass of warm water that sat off our coast that we call the blob. And that directed all the storms to the north. And so that warm water that moved those storms was also hard for marine life. So the combination of the blob and the El Nino, we created what we call a marine heat wave, basically a heat wave in the ocean. And just like on land, or maybe even more so on land, animals in the ocean are unable to shed excess heat and could really be impacted negatively by them. And then the third thing we saw was this big increase in those little spiky purple urchins that I showed you in those earlier photos. For us, we lay down these transects that are about 100 feet long and about 6 feet wide. And on that area, we would see in the past just a handful of urchins, say 4 or 5. And after 2014, we started to see hundreds in those same areas. And meanwhile, like I said before, those sunflower stars, those big ones went from a couple per area, a couple per transect, to almost none. And really, we've seen almost no sunflower stars in the past 5 years. So then we saw these giant kelp declines. So giant kelp went from like a couple hundred, in those areas in that 100-foot long transect, to in some areas 0, and other areas just a few.
How long is a giant kelp? How big is it?
So giant kelp is the fastest growing plant in the world. It can grow almost 2 feet a day. It grows faster than bamboo. And it lives down to a depth of, I guess they go down to 100 feet, but generally you don't see them much below 60 feet. So they can grow from the bottom to the surface and then even spread out on the surface. So generally about 60 feet tall.
And once they're 60 feet tall, they just keep growing outward?
They keep growing out, yeah, exactly. Unlike a tree that has like a stem that goes up, the giant kelp has these floats that just make it float up. So as it grows, the floats pull it up to the surface. And then when it can't float anymore, then it just keeps growing out. And of course, the tide changes, right? And then it goes out.
So they look like balls that you see around the kelp. Those are the floats that are part of the kelp?
Exactly, yep.
And each kelp has got several of these floaters?
Yeah, for giant kelp, there's a whole bunch of the little floats along the plant, whereas bull kelp just has one stem or one stipe, we call it, and then a big, large float up at the top that the leaves come out of, which we call blades. With that decline in kelp, we really saw these ecosystems transform and go from these, rich kelp, beautiful kelp forests to these urchin barrens that were somewhat devoid of life. And so all this brings the question, right? So we saw all these things happen. We saw sunflower stars disappear. We saw urchins increase. We saw kelp disappear. We saw this warm water. How did that all fit together? Like what caused what? The story that I think everyone kind of started off with was that the first thing that happened is that, again, these sunflower stars, these big stars, we know they eat urchins. So the sunflower stars disappeared, the predators disappeared, and then the urchins just started multiplying. Like if all the wolves are gone, then all the rabbits multiply, right? So we had all these urchins that just multiplied everywhere. There was a bunch of warm water came through, and we ended up with this. We ended up with an area of just nothing but urchins, or maybe a little tiny bit of kelp. So that's one story. And there's some reasons to believe that maybe that's not exactly how everything happened. So for one thing, when we look at that urchin boom, so here is that graph we looked at before. This is a slightly different area, but we have sunflower stars declining, and we have these purple urchins increasing. So if you look at when the purple urchin started to increase right here in 2014, that is when we first started to see the purple urchins. But the thing about it is that we don't see them right when they're born. So we don't actually really see them till they get about an inch. Like we don't even count them. That's our protocol limitation, is like we only count them once they're an inch large. So these urchins in 2014 that are an inch, they were probably born a couple years earlier in 2012. And so that's weird because there was still a lot of sunflower stars around in 2012. So it's not like all the predators went away and then all the urchins just started reproducing madly, because that had happened earlier. The other thing about this story is that sunflower stars, they do eat urchins, and everybody knows this, but they don't eat a lot of urchins. These aren't, warm-blooded animals. These are, invertebrates, cold-blooded invertebrates. And it's thought that they eat about 1 urchin per day at most. So that's really not very much. And if you think about that earlier, numbers where I was saying like, in 100 feet, you'd see 2 sunflower stars and 1,000 urchins. It's going to take them a long, long time to get through all those, right? But on the other hand, we also know that urchins will avoid sunflower stars, and we've seen video where they will like run away from them and hide in holes. And so you can have the sunflower stars just kind of scare all the urchins away. But that still brings the question of where did all the urchins come from? And so it could be that what happened was when the predators disappeared, sunflower stars went away, the urchins just came out of hiding, and they were actually there all along. And so maybe when we look at this graph of this huge increase in urchins, it's actually not more urchins. Maybe those urchins were already there. We just see them now because they're coming out of their hiding holes. What an urchin really wants to do is passively eat drift kelp. They don't want to like roam around on the reef where they're in danger of being eaten by something else. They want to stay in a protected crevice and a hiding spot and eat seaweed that just kind of floats up to them, that we call drift kelp. The other thing that happened about the giant kelp is that it did decline, and we saw this big decline, but not everywhere at the same time. So here's that graph of giant kelp where we have a bunch of sites in Monterey. We're averaging all those sites out. But if you take different sites and pull them apart, what you see is that some of them went, to zero right away in 2015. They became urchin barrens. Others, maybe a couple years later, 2017, 2019, became urchin barrens. And some are still healthy kelp forests to this day. So that's another hint that maybe this is a behavioral thing. And then one other thing that we've seen, which is interesting, is that bull kelp, which is that other canopy kelp. It's the one that has the long stipe and the big, float up at the top. Bull kelp has increased since this whole thing, and we think it's because giant kelp would kind of outcompete bull kelp, but bull kelp may do a little better among urchins, and so there's a little bit more of it now, but still pretty small compared to what we see in the past. Okay, so here's the story revisited, or another possible explanation of what happened. So it could be that we had the predators disappear, and we also had these marine heat waves that just caused some poor years for the kelp. The kelp needs that cold, nutrient-rich water to grow well. And so maybe this warm water just made it so a lot of the kelp didn't grow very well. And then because of that, that made a change in behavior in the urchins. So the urchins don't have predators. So they're not hiding from the predators. They're not scared of the predators anymore. And they're hungry because their food has gone away. So now they're emerging from their little hidey holes, and they're moving around on the reef, looking for things to eat. And we ended up with this. We ended up with an area where you have urchin barrens, or just areas dominated by urchins, next to little patches of kelp.
So the urchins eat kelp. So they crawl along,
Yeah.
get kelp and start eating it.
Yeah.
But what happens to the kelp that's above the bottom? How does the urchin get up to the kelp, which is more than a foot off the floor, ocean floor?
Yeah, that's a good question. So urchins eat kelp, right? So if some of the kelp disappears, there might just be not enough food for them all, and they eat what's left. For those big plants, sometimes what happens is urchins will kind of crawl up it and pull it down and eat the whole thing. But the other thing that happens is they will just go and eat the bottom, and then the kelp becomes adrift and it just washes up on the beach. And so you'll see that on the shore. So with those two stories, we're probably both of them are correct in some way. Some of it is probably an increase in urchin, and some of it is a behavioral change. And we're just not quite sure how, even to this day, we're still trying to figure out how all these pieces fit together. And there's probably one thing that some of you are wondering about that I haven't talked about, which is sea otters. What about otters? Because a lot of you probably know that sea otters eat sea urchins. In fact, it's been often believed that sea otters can protect a kelp forest because they eat all the urchins. And sea otters are often referred to as a keystone species, like a building where the whole building relies on the keystone. Well, the same thing is thought about otters, where the whole ecosystem is dependent upon otters keeping the urchin population in check. So when we first saw this outbreak, I think there was a lot of hope that it would be a very temporary thing, especially in Monterey, where we have a lot of otters. Northern California, we don't have otters anymore north of the Golden Gate, but in Monterey, we do have a lot of otters. And so there was a lot of hope that the otters would eat all the urchins and all of our kelp forests would return. But we didn't quite see that. And what we have come to learn since then is that otters do eat urchins, but one, otters tend to be fairly picky. And like all of us, you like the foods that you eat growing up. And because there weren't a lot of urchins when these otters were young, they didn't get accustomed to eating them. Now, that said, we have seen more and more otters eat urchins over time and specialize in otters. So the population of urchin eating otters has increased, which is good. But the other factor is that otters are smart. And these urchins that live in the barrens, and these urchin barrens, the urchins can survive for a long time, but they're not very healthy. They don't have a lot of food inside of them. So the otters will pull these urchins up, they'll crack them open, they'll see that there's nothing there, and then they go somewhere else to feed. And so the otters will eat the urchins that are inside of the kelp forest and protect the kelp forest, but they won't necessarily go into an urchin barren and clear out the urchins from that area, because all of those urchins, they're not good to eat, and otters are smart, which was a bummer. We were really kind of hoping that the otters would save us from this problem. So if otters weren't going to do it, well, what about us? What about people? What about divers? Could we go in and restore some of these ecosystems? And so that's what Reef Check has been working on in the past 5-6 years. And currently, there's a whole lot of efforts underway. These are all projects we're involved in different ways, but there's a number of sites in Oregon. There's 5 projects that are going on in Oregon. There's 3 in Northern California, and there's been kind of 3 projects in Central California that Reef Check has been involved in. And the 2 that I want to talk about are the 2 biggest ones. So one is at Noyo Bay in Mendocino County, so right around here, and another one at Tankers Reef in Monterey. So starting with Noyo Bay, this is in Mendocino County. It's a bay right outside of Noyo Harbor, so it's easy access. And the first thing we did is we set up an area to be a restoration area where we were going to go in and remove urchins. But then we have another area that, as a control area, that we weren't going to touch at all, so that we could compare what happened in the restoration area versus what happened in the control area. And what we did in the restoration area is we worked with commercial urchin fishermen. This was really great because these urchin fishermen, a lot of them were kind of losing their jobs, because even though there's way more urchins right now, just like the sea otters, these urchins didn't have a lot of food in them, so they weren't marketable. Like, even though there's way more urchins, there wasn't good urchin fishing. And so we could, we got a huge grant from Ocean Protection Council, and we were able to funnel that to these commercial urchin divers who could go in there and do all of this work. And work it was. So starting in July 2020, which, the first year of the pandemic, we hired these guys to go out and collect all these purple urchins and remove them from that restoration area and clear it out. It was a tremendous amount of work. Whole bunch of fishermen got involved. In total, we removed over 45,000 pounds, or I should say they removed over 45,000 pounds in just about a year and a half. So a huge, huge undertaking. And it worked. The dark blue line is that control site, the area that we didn't touch. And the green line down at the bottom is the restoration site, the one that we hired these commercial divers to go in and remove urchins from. So you can see that in the summer of 2020, at the beginning, the numbers were pretty close to each other, but then over time, the number of urchins decreased in the restoration area and it increased in the control area. So pretty big difference.
Why do both lines go down beginning in the summer of 2021?
Yeah, I mean, I think that little decrease is like, it may look like a big decrease, but it probably isn't that much. And so urchins do move around, they do die off naturally. The population does fluctuate normally. But I mean, I think what you see is like, they started off pretty similar. The restoration site decreased a lot and stayed low, and the control site increased and then kind of stayed high. Okay, but what we really care about is bull kelp. And so what happened to the bull kelp at Noyo Bay?
Why do you care more about bull kelp?
Well, because we don't really have anything against urchins. You know, we're not against urchins. We just want to have our kelp forest back. We just want to transform these urchin barrens to healthy kelp forest ecosystems. That was the whole point, was to get kelp to grow. And so that's a really exciting part. So after the restoration project began and we started to remove urchins, it definitely took a long time. So we started in July of 2020. They worked all 2020 removing urchins. By spring of next year, there wasn't really a whole lot of kelp there. But by summer of 2021, we did see, you know, a very distinct and noticeable increase in kelp. I should mention that kelp, especially bull kelp, it is an annual. It does kind of grow in the spring and die off in the fall. So there is kind of a natural, you know, progression every year anyways. So you wouldn't expect a whole lot to grow over the winter, which is why there's not a big difference between fall and spring. But it's really that spring to summer increase. And you can see there was an increase in the control as well, which, you know, makes sense because of that annual cycle of bull kelp. But the restoration is much, much higher. So when we removed urchins, the kelp really grew. It grew over the summer. And then it did start to die off again in the fall, like it just does naturally every year. So this was really exciting news. But that said, it wasn't the forest that we had wanted. And so this is a picture of very young bull kelp. And so it has that little root structure called a holdfast and that stem and that little float with the leaves or blades coming off of it. And what you can see is it's just one little plant in kind of a more or less barren area. It's not that rich kelp forest that we had wanted. And in fact, the amount of kelp we saw, it was a big increase, but it was still only about 20% of what we would have expected to see prior to that 2014, 2015 heat wave. So back, say 2013, there was about 5 times as much kelp as there had been at the end of our restoration effort. All right, well, that was all great for Noyo, but what about Monterey? We were interested if we could do something similar in a forest of giant kelp. And the other thing we're really interested in is that it was great, you know, hiring those commercial divers, but we didn't have commercial urchin divers in Monterey. So we wanted to see if we could have volunteer scuba divers reduce the urchin density. In this case, they're actually smashing the urchin. So going down with small hammers and just kind of crushing them, which I think has a lot of advantages. For one, you're leaving the nutrients in the ocean as opposed to bringing them on land and trying to do something with them. You're giving food for fishes and other organisms. And the main thing is it's just a lot less work and it's a lot easier.
How many can a diver crush in what period of time?
Yeah, I say divers can crush about 10 to 20 urchins a minute. So if you're down there for 30 minutes, that's, you know, 300 to 600 urchins.
And they're just crushing them in place?
Yeah, just crushing them in place with little hammers.
What comes along and eats the dead urchin now?
A whole bunch of stuff. So the urchins, you crack them open and they have, you know, their kind of meat inside, and you'll see all these little fish come out of little holes or even larger fish and eat the urchins. And then eventually you'll have, you know, starfish and other invertebrates come and just eat everything. But at this site in particular, after we've been working on it for a while, the fish would get to know divers, or, you know, when divers showed up, the fish would start to follow you, you know, knowing that you're going to be feeding them. All right, so here's the area off of Monterey. So this is the Monterey Marina down here. And this area is called Tanker's Reef. And just like Noyo, we set up two areas. We had a treatment area, which we called the grid, right over here, and then a control area, which we were going to leave untouched. And for this one, to put in the grid, we actually laid down cable on the bottoms. We made this area that was about 100 yards wide and 100 yards long, about the size of 2 football fields. And we put down all this line so that people could go to a lane and start clearing in that lane. Start at the bottom of A and go to the end of A, then go to the bottom of B and go to the end of B, and just kind of methodically clear this area lane by lane by lane.
You said this is a grid we're putting on the bottom of the water and we're marking it by how? Does anybody know where their lane is?
On the surface, there's buoys to mark the corners of the grid. And then on the bottom, there's actually like line rope that goes along, and there's tags for the different lanes. So there's like, A is marked and B is marked and C is marked. Yeah, and it was a huge success. So this group called the Giant Kelp Restoration Project, they organized all this diver effort. And just last year in 2021, they trained over 80 divers who spent almost 400 hours underwater. And they cleared over 225,000 urchins, which was just a lot. It was a tremendous amount of effort. And even though a lot of the focus was on that grid that I was describing, they actually did even more work outside of the grid. So they just did a tremendous amount of effort. And by September 8th, they had cleared the entire grid. They started in April and ended in September. It took them about 6 months, but they cleared that entire, 2 football fields of urchins. And also, like at Noyo, we saw a big response. So these are the numbers of urchins at Tankers Reef. So that restoration began in the spring of 2021. And after they removed them, the numbers dropped dramatically to less, from over 7 urchins per square meter to less than 1. So a really big decrease. Whereas in the control, there wasn't really any change. They stayed pretty flat. And then with kelp, just like at Noyo, we saw a very distinct change in kelp. And this data, by the way, is super fresh. We were just out there a couple of weeks ago collecting the final bits of this data. So we didn't see a huge change last year from spring to fall. I mean, they didn't finish clearing until September. And then on top of that, kelp takes a while to grow, and then it's also seasonal, so you don't get a lot of growth in the fall anyways. But all those divers, they were able to keep clearing that grid and maintain no urchins on it all winter long. And so this year in the summer, we've seen a ton of growth. And I'm anticipating that line is just going to keep going up, because I think there's more growth that will happen this year. So a super encouraging result at Tankers Reef.
So how many people are involved in the project? How scalable is this technology?
At the time last year, they trained over 80 divers. I think at this point, it's well over 100 divers. And those are all volunteer divers. They're not being paid. Those are just divers that are like volunteering to go out and do this work.
Only 387 underwater hours.
Yeah.
That's like a month of one person underwater 10 hours a day.
Yeah, and I think the thing to remember is that they can't work 10 hours a day underwater. Your scuba tank only lasts about an hour, if even, more like 45 minutes in most cases. And then you got to come back up, and of course the water is cold. It's 50 degrees, so you got to warm back up and get back in. So, doing 2 full hours in a day is a lot of work. So that 386 underwater hours, I mean, that's probably 300 days of work. All right, well, so that brings me to where do we go from here? So we have shown that these efforts can restore kelp, maybe not to the stage that we want them to, or maybe in a couple of years they could, but they are also fairly small areas, like even 2 football fields. It's a big area, but if you think about the scale of the coastline, there's really no way that divers could clear this entire thing. But we can keep working at it. So one thing that we do know is that when things do change, and we have seen the areas change naturally too, places are more likely to transition from a barren back into a healthy kelp forest if there is healthy kelp nearby. So one thing we can do is we can go around the state, go up and down the coast, and make sure that there's pockets of healthy kelp everywhere that can repopulate the other areas if the urchins do go away or if sunflower stars come back. So we definitely want to keep working. We want to expand this work. We want to go into new areas, especially areas where we're seeing urchin barrens develop. And then the other aspect, we need to continue to understand what is going on and what all these causes and effects are. Because if we can figure that out, if we can unlock that mystery, then maybe we can change the conditions where kelp can come back on its own. And for that really just takes the science. It takes divers going down, collecting data, making observations, and giving that to scientists to analyze and figure out. And it's our hope that if we keep doing that, if we keep plugging away at these restoration sites and protecting some areas and collecting data on the changes that we're seeing and why, we can transition those areas, back into these like beautiful, rich kelp forests that provide homes for so many fish and so many invertebrates, and are economically important and socially important, and are really just these ecosystems that I certainly know and love and just find really amazing.
I see urchins on the seafloor, but I also see urchins going up on the seaweed itself.
Yeah.
Are they crawling up the seaweed?
Yeah. They will crawl up the seaweed and even crawl up the stipes or the stems to eat kind of the more leafy blades that are up higher.
When they eat through the bottom of the stipe, at the moment they gut through it, doesn't the stipe float to the surface then?
Yeah, it definitely will. And eventually that will happen. Like the stipe is a little bit like the wood of a tree.
Yeah.
And the blades are kind of more like the leaves. And so the urchins will eat like the bark, but they prefer to eat those leaves. So they will crawl up to eat kind of those more leafy parts, but eventually they just mow through the bottom and eat the whole thing, and it just goes.
In this particular case, how fast do these urchins move?
They move about as fast as snails move, so pretty slowly.
So let me say that while I'm so happy that somebody is paying attention to what we can do to restore the kelp forest, this presentation has made me more fearful that we don't have a scalable remedy. So I'm very interested in your solution, how scalable it is.
Reef Check has been around since 1996, and we actually started working in coral reef ecosystems, where at the time we were looking at the health of coral reefs. And there was a lot of studies that had been going on, but they were all small studies run by different universities who didn't necessarily talk to each other. And our question, what we wanted to look at, is what was the health of coral reefs globally? And so we wanted to build a global monitoring program. And the way we did that was using citizen science, so volunteer scuba divers, sometimes local fishermen, sometimes local dive shops. But instead of paying PhDs to fly all over the world, we use local knowledge and local experience for people to monitor their own reefs. And that was actually really instrumental in recognizing that coral bleaching, which is something that we all know about now. But we identified that was a global thing that happened kind of all over the place during these warm water events versus something that just happened to local coral reefs from time to time. In 2006, we started in California with a similar goal, where we wanted to expand the amount of knowledge that was being collected on our nearshore ecosystems, in this particular case, in our kelp forest along in particular the California coast. And we did that using volunteer recreational divers, and we taught them our scientific diving protocols and had them go out and do these fairly complicated surveys to collect all this detailed information on the health of our ecosystems.
And so people who want to fund Reef Check, where would they go? How would they, how they help?
I'm so glad you asked. That was my next slide. So yeah, we definitely do need help funding this project. The Noyo project doesn't look like we have money to continue that. And these projects that we want to expand, we're always looking for additional help so that we can do this important work. So please help us out. You can go on to our website. I got that QR code there. You're also welcome to send me an email at dabbott@reefcheck.org. And I would love to connect with folks and talk about how we can continue this important work. We are a freestanding 501c3. We do partner with a lot of other schools and aquariums and government agencies like NOAA and California Department of Fish and Wildlife. And we've kind of built this network of people that do this work.
And so if somebody contacted you who was a diver, you'd give them, you'd explain your protocol, how they could contribute, and what kind of tools they would have access to so they could contribute to your database, et cetera?
For sure. So if folks are divers and they want to get involved, we do Reef Check protocol training classes every spring. And they're fairly, involved classes where we really put you through the ringer. We teach you all this fish identification and species identification, all these scientific diving protocols. It's a lot of work, but it's a lot of fun.
So seaweed, is seaweed a coastal phenomenon? Because you said it's not, when you have 1,000 feet depth, you don't have seaweed much below 100 feet. Is seaweed coastal?
Yeah, so, seaweed, just like plants on land, needs light to photosynthesize and grow. And in the ocean, the deeper you go, the less and less light there is. So it really grows in, relatively shallow waters. It can get down to 100 feet or more. But, the shallower you are, the more light there is. And so that's going to, that means a lot to plants.
Is seaweed on all the shorelines of the world's oceans?
Well, the other thing that seaweed needs is it needs nutrients. So just like in your garden or on, farmers, you need phosphate and nitrates. So you need light and you also need nutrients. And so some water, especially, the kind of warmer, less nutrient rich water, you don't see a whole lot of seaweed growing there, especially not these macro algae, these large algae. So it is nutrient limited. And one of the things that's incredible about California is that we have incredibly nutrient rich water. And that's because of those winds that all you sailors love. They push like the mass of water kind of at an angle offshore and bring up this cold water from the deep called upwelling. And when things die in the ocean, all that material floats down to the bottom and all those nutrients just sit there. And so this upwelling brings this cold, oxygenated, nutrient-rich water, which allows all this life to grow, which is why we have such an abundant ecosystem off the West Coast. I wouldn't say all coastlines have seaweed. I think there's some areas that don't have nutrient-rich water, like most of the tropics, even though they seem really beautiful, the water doesn't have a lot of nutrients in it, so you don't get as much algae. Same thing with like colder Arctic ecosystems. You don't have that level of nutrients. And in coral ecosystems, we have something called coral bleaching, where the coral kind of dies off, and then you have an algae that grows over it and kind of isn't good for it. So in some areas, those marine algae are bad.
Dan, it's been fascinating listening to how a Reef Check is endeavoring to monitor and restore the kelp on our coastlines. I see how important it is. My goodness, it is like a forest that can help support sea life. And so we wish you the very best of good fortune in your ambitious task. And we hope that viewers of the Wednesday Yachting Luncheon will support your organization, by sending in bucks and or offering volunteer efforts. So thanks very much for being a presenter at Wednesday Yachting Luncheon.
Well, thank you so much, Ron. Thank you for the opportunity to present, and thanks to all of you for listening.
This has been a presentation of the Wednesday Yachting Luncheon.